Okay, the next section is to calculate the force on a plane once the plane is inclined and immersed relative to water surface. So we have, first of all, we need to just locate the resultant force. The resultant force is similar to the vertical force formula. So the same formula for inclined surfaces is the LP is equal to, open the bracket, IG over A times LG, close bracket, plus LG. So if you look at the shape here, if the surface, if you look at here, the shape here, figure B here, if this is the plane, inclined angle has got an angle to the water surface like this one, has got a depth of D and the force applied in some specific locations. And if the centroid is denoted by G, the distance, the inclined length, so all of these, like the parameters of LP and LG, are inclined length. So we're just going to need to just extend this kind of like the surface, extend that one to get to the surface, to the intersection to the surface. So the inclined length of the centroid to the surface is called LG. So the one that we're just going to use in this formula. And also the center of the pressure, the point that the resultant force will act on. For example, let's say this is like the F will act on this point, point P, the center of the pressure. The inclined length of that point to the surface level, so we just noted by LP. So the LP is calculated based on this formula. So you can just use here. So the only thing that you need to do is to calculate the center of the area or the center of the surface, which is like the LG. And we need to just have the area, and we need to just have the second moment of the area, which is the AIG. IG, which is the second moment of the area, about point G, and vertical, like the, for example, second moment of the area. So we just have like in this kind of like a shape, which is exactly the same as the one that we're just going to calculate for in this figure in the middle. So we can have like a HG and HP. So we're just going to use the same formula as that one. So you can see in this, then the left-hand figure, you can see the distribution of the pressure is distributed diagram, vertical, in right angle to the surface, to the plane area. So you can see like this one, and it looks like a trapezoidal shape. It started from this point and ending in this point, and that is the area, and everything is the same. So to understand better what does it mean, so let's look at the one example here. So we have a sewer discharge like this one. A sewer discharges to river. So this is the sewer discharge to the river like this one, with a circular gate with a diameter of the 0.6. 0.6 is the length or the diameter of the gate, which is inclined. The gate is in incline at an angle of the 45 degree to the water surface. You can see in here. The top gate in here is 1 meter below the surface. You can see here the top gate, or the top edge of the gate, is 1 meter below the water surface. And so we need to calculate the resultant force of the gate, on the gate caused by the water in the river. So we need to just calculate the force from the river, which is the aggregation of the pressure distribution, and also the vertical depth of the water surface to the center of the pressure. So the vertical depth of the water surface from the water surface to the center of the pressure. So we need to just have vertical depth. So bear in mind, not inclined length of the center of the pressure. We need to just calculate. So you can see here, if we just gonna like the, if we can just plot the inclined length of the LG and LP, we can use this one from the formula that we learned. So we can calculate LP, and then we need to just convert this inclined length of LP to the vertical length, because the question here, section B, asks for the vertical depth from the water surface. pay attention to this point as well. So let's look at how we're just going to go ahead with this one. So first of all, we need to just calculate the force, resultant force. To calculate the resultant force, as we learned before, we need to just calculate the centroid and vertical depth of the centroid. And once we calculate the centroid or the center of the area, we can easily use the formula rho g hg times the area to calculate the force. So let's just see one by one. So the centroid we know is like a center of the gate. Let's see if the gate, for example, the gate in this case like circular, like with the circle cross section. So we have that one. So obviously the center is exactly in the middle of that, is here. So we're just going to need to see what is the vertical height of the gate. So the vertical height of the gate we need to just calculate, because we can have this one, we can have 1 meter. If we know the vertical depth height of the gate, like this height, we can easily calculate half of that. So if we're just going to have the vertical, this one is like 0.6 meters. So the vertical height of the gate, by using the trigonometry, we can easily set that this, the vertical one, looks like a triangle with the right angle in the right angle. So you can use the 0.6 times sine 45. This is like the sine 45. It's like a triangle shape. And here we can just easily use 0.6 times sine 45, which is equal to 0.424 meters. So this is like this section. So the vertical depth or the vertical height of the gate can be easily calculated based on the trigonometry, Pythagoras formula. You know how to calculate this one, very simple. And the vertical depth can be calculated. Half of the vertical height of the gate plus the from that point to the top, which is 1 meter, will give us the vertical depth to G. So the vertical depth to G, half of this like the 0.424 plus 1 meter, which is equal to 1.212 meters. So this is a vertical depth. And so we're just going to calculate. And so this point is called HG. HG is calculated like this one. So the area is pi d squared over 4 pi, and d is the diameter of the gate is 0.6 squared over 4, which is the area which is equal to 0.283 square meter. So this is like the area. So we need to just substitute all these parameters in the formula. Rho g hg, rho is 1,000, g is a 9.81, and hg is a 1.212. We calculated here, and the area is 0.283. The result is 3,365 newtons, or 3.365 kilonewtons. So this is like the section 1. For section B, the way that you're just going to use exactly the same formula, we're just going to use the slope length or the incline length of, let's say, to G. The point G is LG. The way we're just going to calculate, we calculated HG. So, okay, based on the trigonometry, we need to just calculate the hypotenuse of that triangle. Hypotenuse of that triangle is equal to the HG, which is 1.212, divided by sine 45 degree. Okay, this is like the sine. You should easily calculate that one. This is equal to 1.714 meters. This is the incline length, or LG. And for the second moment of the area, for the circular cross section, we know this is the formula. IG is equal to pi r raised to the power 4 divided by 4. Pi times 0.3 is like the radius of the gate. Diameter was 0.6. Raised to the power 4 and divided by 4. So all of them is equal to 0.0064 meters raised to the power 4. Okay, so it's the IG. So we're just going to substitute everything in the original formula. This formula is given to us. So this is equal, open bracket, 0.0064 divided by A. A we calculated before, 0.283 times in denominator. This is the denominator actually. times the LG, 1.714 is here, plus the LG, 1.714. The result is 1.727 meters. However, this is not the answer. The answer is asking a vertical depth from the water surface to the center of the pressure. So to calculate that one, we need to just use the, again, the Pythagoras formula. So, or like, let's say, based on the trigonometry, we say that like LP, or hypotenuse, times the sine 45 will give us the vertical depth to P. So LP sine 45 degrees, which is a 1.727 times sine 45 degrees. This one is equal to 1.221. So this is example 3, or the last sections of this section, which is all about to calculate the force on a plane which is inclined and immersed to surface. Thank you very much.